Good evening, everyone. My name is Simon, so pleased to have you here. Pleased to see so many people here. A bit more larger numbers than we had in the beginning. We're recording, yes?
We are recording.
Check.
Yes.
Hello to the one person watching us from far away. So this talk is called Demystifying Machine Learning. The idea behind it is that there's a lot of buzzwords and a lot of hype and a lot of and also science fiction doesn't really help us because we get characters such as Skynet and Terminator, so we aren't left with much to imagine with regards to AI and machine learning. Yet this is not the future, this is the present and not the past at this point. So products we use every day use machine learning. Even governments and large institutions are starting to use machine learning for various purposes, whether positive or negative. So it's good to be aware of what it actually is, what's involved, what it boils down to. The blurb said how before you get into programming looks like magic. I still get comments like you're a wizard, you're a genius, even with the simplest of programs. In reality, when you enter it, it's just simple instructions to a very obedient computer. Even if you write the wrong thing, the computer will happily let you blow it up. But then, even as a software engineer, you hear these things about AI recognizing traffic signs. I don't know, diagnosing cancer before it happens, stuff like this, and you're like, wow, this is magic. I could never write a program with just this. And then you get into it and you realize it's just linear algebra. So if you know, like basic maths, you can basically understand most of it. So let's get on with it. This is on, this is not on. So this is my outline of my talk. I'm going to explain the reasoning behind it, which was what I just did now. I'm going to define AI, machine learning, or the buzzwords. You might need to clarify it, so raise your hand. I'm going to explore some examples of machine learning. I'm going to dive down the rabbit hole and to see what machine learning using specifically neural networks involves. There's many ways to do it, but neural networks is one of the most popular right now. I was going to train and test neural network live. I had a demo already, but it takes a bit long and we don't have time, so maybe afterwards I can show it off. I'm going to take a look at what defining a neural network looks like in Python. There's various reasons why we use Python has emerged as the most popular for it. I'm going to explain why machine learning has become so popular only recently and why it hasn't been popular since the 80s and so on. Artificial intelligence started with Turing, but that is very theoretical and only recently has it entered the world of practice. I'm going to explain what issues the increased involvement of machine learning and AI brings to our daily lives. And then there's some concluding thoughts at the end. So let's get started. Reasoning. What I said, but it's out there, whether you like it or not. You're affected by it, whether you like it or not. You should be informed so you can avoid propagating false information or so-called fake news. Getting worried and scared when you don't need to. No, Skynet is not taking over the world anytime soon. And that's in fact believing that the robot uprising is imminent. And the most important one is to understand the simplicity behind something which can so much seem like magic. Okay, let's get this out of the way. AI. AI stands for artificial intelligence. There's a difference between weak AI and strong AI. Weak AI is defined as a machine, or if you will, which is capable of exhibiting intelligent decision making. So this can be as simple as there is rain, let me turn on the wipers, or it is dark, let me turn on the headlights, to how should I invest my savings into Bitcoin, whether I should invest it now or later. But strong AI is an intelligence which is exhibiting consciousness. Usually, weak AI involves practice. Strong AI involves philosophy. And sometimes the line can be a bit fine whether you're dealing with weak or strong. Most of the time, we're dealing with weak. There's three aims to AI. These are called the engineer's aim, which is to make better machines. Then there's the philosopher's aim, which is to understand intelligence, what intelligence actually is. And then there is the psychologist's aim, which is to understand better how the human mind works. if through AI can we sufficiently simulate a human brain, can we better understand how humans work? That's a big question mark. So by extension, machine learning, which is a subset of AI, it is a system which learns. So through its operation, it learns. Eventually, it will start making better and better decisions. There's three ways of teaching a learning system of learn. One of them is supervised. A supervised system is I want to teach it how to recognize the number 1, and I tell it that it's the number 1. I want to recognize letter 2, and I tell it it's letter 2, and so on. You are explicitly telling the AI what it should be learning. Unsupervised learning is more about, it begins to slowly blur with data science a bit because it's about aggregating data. Ideas such as if I have customers, the customer might buy CDs about rock music. How would the AI aggregate this customer data that my customer who buys rock music might also buy motorcycle replacement parts? Because when you plot it out, the AI might recognize that to aggregate them in similar ways. And reinforcement learning is the idea of you give an AI a situation, it begins to try and play against rules in a game such as chess or Go or whatever I mentioned this later on. And for every bad move it makes, you take away something. For every good move it makes, you give it something, and so on. For example, if it wins the game of chess, then you give it a big reward, and it learns that it should follow that pattern more. Blockchain has nothing at all to do with AI or machine learning, and no, you do not need one. Any other buzzwords? Raise your hand or forever hold your peace. Anyone? No. Okay, good. So, machine learning examples. This is one that part of my thesis was on this. It's detecting and organizing traffic signs. These are actually two different applications. Detection is, I've given you a picture, tell me whether there is a traffic sign in this picture or not. And if there is one, where is it? As opposed to recognizing, which is this a stop sign or is this a 100km/h sign, which, as the XKCD comic over there, which we can all read it, it's small, makes a very good point about. For the ones at the back, it says, complete your registration, please tell us whether or not this image contains a stop sign. No or yes. Answer quickly, our self-driving car is almost at the intersection. Keep going. Two very good examples is defeating the best human chess and Go players. Back in the 1980s, 1990s actually, I think it was 92 or 93, Garry Kasparov, which was a grandmaster at chess, played against Deep Blue, IBM Deep Blue, which was quite a simple AI by our current understanding of AI, which is a simple search problem, which would find the optimal move against its opponent. Garry Kasparov first won and then lost 2 games, and it became the first case of a human player losing in a human game to an artificial player, if you will. I remember, if you look back, you can find magazines with headlines of, is this the end of humanity, sort of? Whoops. Is this the end of humanity? We lost the chess. Are they going to take our jobs? And so on. Only it got much scarier. But I don't know, I think 2015, the DeepMind startup, which is by then already owned by Google, created AlphaGo, which played the game of Go. The difference is that the game of chess, I think, has a board of 8x8 squares, whereas Go is 19x19. So the amount of possible moves that you can make is much, 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 much larger. To the point where it suffers from what's called a combinatorial explosion, where the amount of combinations is so large that even with infinite processing power, you probably can't keep up with it. But still, it defeated Lee Sedol 1-4, to the point where in Go, there's like a ranking, if you will, like an official organization which handles ranking of players. And they assign the highest possible rank to AlphaGo, which is not even human. And the highest ranking, if you read the rankings, they've got like fancy names. It's like his skill is heavenly. There is no other skill higher than this to play the game. Okay, This is an interesting one. This is, in painting is a process whereby if you have an image, you want to remove something from it, but not simply leave empty space, but efficiently fill it in. Right? There's a bit of a very, very interesting video that let's hope it will work. Hold on. No? Yes? Maybe? So just sit back and enjoy. There's some inspiring music, but you can't hear it. That's as loud as it goes. Oh, it's probably coming out of the system if it doesn't have. But anyway, just enjoy it. Basic idea is that the human operator here is highlighting an area region on the image on the left side, and after a few seconds, the AI is efficiently in painting it out of the scene.
You don't have to use the scissors to cut ex-wives and girlfriends from.
Yes, exactly. If you get divorced, you can just in-paint your wife out of all of your photos. For full disclosure, this video was like a PR piece by NVIDIA because they make a lot of profit selling hardware which runs AI. I'd like you to note the inefficiencies when it comes to human faces because I'll talk about the fragility of AI later.
Is it worse?
It gets worse.
His hair was messy. More realistic now.
Yeah, this is a fun one.
Same ladies.
Okay, let's go back to this. Okay, so anyone got scared after seeing that? You don't have to be. So let's dive down the rabbit hole. How does a machine learn? Well, it depends on the machine. One method is using artificial neural networks, and usually right after saying this, I get the question, but are we making brains? Well, brains use neurons, and artificial neural networks are inspired by biological brains, so let's dive into that history. The biological neuron receives an electrical signal into what's called the synapse. The neuron's internal structure then, according to some chemical processes, depending on its input, decides whether it sends that electrical output again, and that output is sent down the axon. A biological neural network is simply several neurons already connected together. The output of the axon there is a pointer. The axon on the right side ends up serving as the input for other synapses. And to get an idea, because this is also very important to understand, human brains have around 80 billion neurons. Okay, so what's the difference? The artificial neuron is inspired by the biological neuron, but it's not necessarily a simulation of one. The input instead of electrical signal is a number. So this can be a number, it can be an integer, but it's usually a decimal point, or it's in fact usually a float or a double. So it will be 0 point or 1 point something, as many decimal points as you can. And the neuron decides on whether to fire depending on what's called a net function, which is a mathematical function. The net function is how it interprets inputs. It might give bigger weight to some inputs and less weight to other inputs, and that's decided in the net function. And then it decides whether to fire or not according to the activation function. Activation function varies. I'll go into some examples later, but can be as simple as it passes the same number out, or if the number is less than 0, it outputs a 0. If it's greater than or equal to 0, then outputs a 1. And yeah, and then the neuron output is out of the activation function. And by the same logic, an artificial neural network is just artificial neurons which are connected together. In a biological neural network, they are literally physically connected. However, here we're talking about numbers in memory space, in RAM or on disk. So not actually connected together. The connection rises as a part of how we move our numbers around. The activation value of one neuron acts as the input value of the next, and they typically have tens of neurons to tens of thousands of neurons. So there is several orders of magnitude difference between an artificial neural network to a biological one. And here's just a simple example of how we can have a simple artificial neural network. So there are two main uses of an artificial neural network. One of them is prediction, which answers questions such as, what is the temperature today, given, here I say arbitrary inputs, but things such as, what's the wind distance, wind speed, what's the wind direction, what was the temperature yesterday, what's the pressure, what's so on and so forth. You feed that in and you get a number out the other end. And the other one is classification, which is you know that the answer will be a subset of certain things. For example, what kind of traffic sign is this? And you have 50 traffic signs, no more, no less. Or what number is this, from 0 to 9? You won't invent a new number. It will have, the answer will fit into one of those. Okay, this is, maybe we'll do this after, but there's source code if you want to read it. So sample neural network, I found an example which uses Keras, and I'll use TensorFlow as a backend, say what are all these? TensorFlow is a library by Google. This library handles the creation and operation of what's called a tensor board, which is a fancy word for something which can also simulate a neural network. Whereas Keras is a library which uses TensorFlow, but as a backend to run the actual computation. However, it just makes the definition of the neural network much simpler. And it can use a variety of backends. You don't have to be limited to TensorFlow. So, for example, we're going to use a NIST. This is like the hello world of machine learning, so strap in. This is an image. This is a data set of hand-drawn numbers. So it's a good classification problem because we know there's only 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. And the way we break it down and feed it into the network is that this is, for example, a 28 by 28 image. And the brightness is a float number between 0 and 1. So simply put, if you're wondering how a neural network understands an image, it's just literally an array of arrays. And in fact, usually we just flatten it and make it a long array of float numbers, which is where the word tensor comes from. A tensor is a one-dimensional array of floats. So then we pass in our training set into the network, but we also have labels. So we know that every image in this row is a 0. We know that every image in this row is a 7. So this is supervised learning. The network knows what the answer should be at the end. Okay. Oh, I had to do it. So I did not prepare this beforehand. No, we don't need sound. I'm literally loading up PyCharm. Oh, oops. This is a very good video on machine learning, but oops. Hold on. Let's do this live. So this is actual. I'm sorry if you can't see the code, but we've tried to increase the font size and it never works with PyCharm. No, I've tried. If you know how, please raise your hand. Anyway, the idea is that here we're importing Keras up here. Then we're going to import the NIST as our data set. Most of these libraries make the simple or most popular data sets available where you can download it. We're going to have yes, a sequential model, which means that we just have numbers after each other in our tensor. These are types of layers. Don't worry too much about them. Yes, and we're importing a backend. I already have TensorFlow running here on my laptop. It's installed. Here is a bunch of wrangling to get our data, so because it's like stored in CSVs and so on, and then it's like compressed and so on. So that's just a bunch of boilerplate. But to define our network, it's this simple. Our model is sequential. We're going to add a two-dimensional convolutional layer. pooling layer, the idea is that this is a layer, it's some specific type of layer. These are, for example, a dense layer is where all neurons are interconnected. And we're just adding layers. Here we're stating our activation function. The ReLU function is, if it's less than 0, then leave it as 0. But if it's greater than 0, then just output the same number. And then we've got this softmax is something else. And literally we just compile our model and we tell it fit to our training data and tell it to run. And I know that Hollywood has a bit of a, what's the word, monopoly on making AI look really cool, but I'm sorry to say it looks extremely boring when you start it. Excuse my tiny CPU. So here, this is the number of iterations that we're teaching the network. Here is the estimated time till we end our epoch. We have our loss, which is how far away we are from 0 loss, and our accuracy, which is slowly rising. The more we train the network, the more accuracy is rising. Here it's a float, so here we're currently at 64%, and it's nice and slowly rising. If we leave this running, it's going to run for about 60,000 times. It will eventually reach, I think, around 98% accuracy. I'm sorry to say, but it looks much more. It is more boring than it looks. When it comes to this part, because this part usually you just have to sit and wait.
Where is it being trained?
It is being trained on recognizing the handwritten numbers.
And what's the result of this run?
The
result?
The result would be, then you pass in any of the numbers, a handwritten number, any arbitrary handwritten number, so not part of your training data set, and it should hopefully, to 99 or 98% confidence, tell you which number it is.
I just think in the menu, there's view, presentation mode.
The font size?
This?
Yeah.
Oh, and does it help?
Oh, okay. Nice, but now we can't see the terminal.
Oh, yes. Sit here and shift.
What?
And right one. There, right one.
Oh,
No,
I
look.
see the research.
Hold on, I'm trying to do this with a microphone in my hand. Oh, we're also training the
Brilliant.
okay.
I think
Let's try. Oh, yeah. Anyway, it's okay. How do I exit presentation mode?
Good luck.
Control presentation. Presentation.
Toggle presentation mode. There we go. So now we've lost our terminal though. How to bring up the terminal?
View.
View.
Alt F12.
Alt F12? Yes. Thank you. No, the other one. The one that's running.
I don't think it's running anymore.
No, I almost did Alt F4. Hold on. But anyway, it will eventually arrive. If we probably bring up Task Manager, I can see my laptop burning.
Is the output like a matrix? It's a binary file? What is
So the output will be, actually it will be a tensor fact we are running at full speed here.
Oh, it's running. Good.
We'll know when it finishes in a bit. So what will the output be? The output will actually be a tensor. It will be a tensor of 0 to 9. It will have 10 things in it because we can classify to 10 different numbers. And it will be a float of how confident it is. So typically it will be something like we are 95% confident it's a 5, and we are, or for example, an 8, but we are 2% confident it's a 9. So by then you'll need some sort of threshold where you're like, you know, once it's that confident, we're like, it's definitely a 9, or it's definitely 8. Yeah, we can keep going. If I manage to. Okay, there we go. So back to this. Okay, so now I'm going to expand on why it's become so popular recently rather than before. And one of the main factors is hardware. We used to run things on CPUs, and then we started running them on GPUs because you can update every single part of your network, or at least one layer, or even layers in turn, all in parallel. And graphical processing units, while they were designed to update pixels in parallel, we discovered that they're actually just useful as general purpose parallel processing units. So they were extremely useful for neural networks. And then there was the Google TPU, which is a chip literally designed to process tensors, which goes even faster. The TPU there looks small. It looks as big as a GPU, but these things are just big. They fit in huge pods in data centers. You're not going to fit one of these in your computer. Just to give you an idea, a teraflop is how many floating point operations you can run at a given moment in one cycle. The CPU, like this is like Intel i9. This wasn't even released when I made the presentation. Can run around 1 teraflop. The 1080 GTX Ti, which is a high-end current gen GPU, can run 11.3, and the old TPU, because the Gen 2, because there's the Gen 3 TPUs, can run 180 teraflops. So there's several orders of magnitude difference. Okay. Main factor 2 is framework support. Before, everyone used to code their own neural network by hand each time. So you'd have, development time, bugs, and so on. However, with framework support, you have less time making a network and more time making a better one. You don't have to stay coding your neural network from scratch. Just use any of the widely supported networks that are available, such as TensorFlow, there's CAF, there's Torch. Most of these have their Python variants. TensorFlow is written in Python. And one of the lovely things is hardware support. The same code that I run exactly. I don't change anything. I don't even change a configuration file. The same code I run on this, I could run at home on my 980 GTX. I could run on a Google Cloud instance, which is running like a whole pod of TPUs. Because the framework just abstracts away. It's just give me what to run and I'll run it on the best available hardware I have. And main factor 3 is big data, which is another buzzword, but basically to do any useful machine learning, you need data. And this is thanks to the so-called, another buzzword, the Internet of Things, smartphones, which now have a bajillion sensors, and online tracking, like cross-browser and cross even machine fingerprinting, so they can like track of what you buy and so on. They have even more data to make more predictions. So now we're going to take a hard left turn into the bad news. One of the main problems with machine learning is bias amplification. This was a statement which I found in one paper, which is man is the worker that woman is too. And these researchers, they trained a model on Google News articles, and the model was returning man is the worker that woman is the homemaker, which is a bias inherent to maybe our social construct, if you will, right now, that we're actively trying to avoid. But the problem is that if we train our system on biased data, our system will be biased. Now, whether this bias is part of social pressure or whatever, that's another story. But the problem is you have to be aware that if your system is if your data is biased, your system is also going to be biased. Overfitting is the problem of if your data set is limited, so you only take photos of traffic signs on a sunny day, and the second it's going to be foggy, or the traffic sign is slightly bent, or in Malta you find some Jesus loves you sticker on the middle, it's going to pay. And what if your neural network in your self-driving car misclassifies a stop sign for 100 km/h sign? Who's responsible? That's a question I'll get to later. Actually, here it is. Loss of accountability. If AI fails, who is responsible? Is it the programmer? Is it the model? Is it the person using it to accept the terms and conditions? Is it the person who designs the framework? Because I said the framework was a good thing. Having framework support is a good thing. But if Google have a bug in TensorFlow which causes eventually loss of life, are they responsible? Big question mark. So I'm going to go into some recent disasters. You can also call them growing pains. One of them was Google Photos tagging a specific dark-skinned person as a gorilla. Here you can see Google Photos released this auto-tagging feature where things like skyscrapers, airplanes, and gorillas Oops. Yes, the fix from what I hear through the grapevine is that they had to manually stop it from, they had to debias it from tagging the person as a gorilla, not finding more data. But yeah, let's not get into it and let's not perpetuate false information. Face ID, which was Apple's fancy, we're not going to have a home button or a password. We can just point it at your face and it will unlock. This is feed by a mask. This is a 3D printed mask with some 2D printed images glued onto it, and it was defeated by it. Oh, this was a very interesting paper. Innocent-looking graffiti, which can have extremely malicious results. In this paper, they placed very innocent-looking graffiti like love or hate or just boxes on the stop signs, and they had success rates in excess of 95% of misclassifying the sign on purpose. So the idea is, I'm maliciously trying to misclassify it in both physical and virtual settings. So that, that Jesus loves you sticker could potentially be deadly. And yes, this was a very recent, very unfortunate disaster of where an autonomous taxi misclassified a woman crossing the street with her bicycle and ended up running her over and killing her. And then recently there was also, this was an Uber, autonomous taxi. Recently there was the Tesla, the Tesla autopilot, which misclassified, I think it was a bus with advertising on the back of someone on a bicycle, and the car classified it as a bicycle because it's not a bicycle. So concluding thoughts after everything, AI and machine learning are just yet another tool that we can use. They're going to enable great progress and enable us to do great things which we couldn't do with normal imperative programming. But over-reliance can cause unnecessary loss of life, value, and/or property. So any questions? Forever hold your peace. And thank you for listening.
Who wants to ask a question? Oh.
So you mentioned the frameworks. You mentioned the frameworks. Go Amplitude and Torch. A very basic question. I'm not into AI, and I can't learn all the frameworks. So obviously, I need to choose one. Have any recommendation? First, you might say it depends on what. Depends on what you want to do.
Actually, it doesn't.
AI.
So it doesn't depend on what you want to do because like any good framework, it should abstract enough details to let you do whatever you need to do. The way that Class for Django can let you both make a static side statically generated website, as well as make a REST API, as well as other things. But the framework is the same. And it's the same case here. Not only should the framework be generic enough of that you make any kind of AI you want, but AI itself is also an abstraction for what there's a second step of you need to know what kind of AI you need for your problem. But my recommendation would definitely be TensorFlow, but not pure TensorFlow, not if you're starting off, because TensorFlow is it's designed as a what's called it lets you create computational flowcharts, which is a complex way of defining a neural network. But it lets you also define a neural network. It also lets you define other things, but it also fits for neural networks and for AI in general. So I would suggest install TensorFlow as a backend and use Keras as a frontend, and start from there.
What's the name of this one?
The frontend, Keras. Keras is a library which it consumes different backends. Like one of the backends uses TensorFlow. So you need TensorFlow to use Keras. And another point I forgot to mention is the reason that Python is so popular, became so popular, is because Python is one of the easiest languages to perform FFI, which is foreign function interface. We already had NumPy and scikit and all of these fancy libraries which are written in super fast C, but then we just wrapped in a bit of Python, and any ordinary Joe or Jane can use it with Python, which is like gives you super simple syntax. And the same happened with AI and with TensorFlow. So they wrap around these fancy, complicated libraries which make life very fast, but then they give you the simple syntax which you need. Anyone else?
Any questions? Okay. Would you recommend actually learning the basics rather than jumping into a framework? Because just imagine that, well, everybody knows jQuery, right? So the people who actually started off with jQuery, they don't know how to do the actual keyword JavaScript, right? So my question is, would you recommend rather jumping into a specific framework like TensorFlow, or just learn the basics and start like some simple stuff?
So I would definitely suggest, if you're interested in the area and to understand better how it works, which eventually should hopefully lead to you making better products if you want to make a product with AI or even just an experiment, you should definitely try to implement a neural network on your own, or follow a guide which is like simply, neural network in 15 minutes, or there's a lot of these guides on the internet, because it involves, just as I mentioned, linear algebra. You know how to do times and plus, then the equations, just use those. They're not like super complicated integrals and whatever. You can basically do it with secondary school maths. So I would definitely suggest you do that. And then I would also suggest you jump to Keras, because TensorFlow, so high-level libraries, can't Keras or something else, because TensorFlow and the others can become so complicated to define even the simplest concepts that you will end up giving up, or just copy-pasting stuff from guides and you don't know why it's doing something, or why we define certain things. So I would actually recommend the jQuery approach, if you will, but first try. So if you start with the higher end library, and then if your product does need to scale up to consumption by users, maybe consider translating it to TensorFlow or whatever backend you use. But yes, first try implement one on your own. You can do it in any language. I did it personally in both Python and JavaScript, and it didn't take me more than a day. But then use a high-level language to abstract all the funky details away. Next.
Any other questions? I'd like to have a comment. Because you mentioned that, I just have a comment that you mentioned that beating the part was less intensive, less problematic than beating the Korean guy in Go. Yeah, I just wanted to say that the number of possible positions in chess is possible to put in the memory. Yeah? So it's so small that you can actually make an algorithm to figure out what's the better move. And the number of possible positions in Go is actually, I just checked, 10 to the power of 170, something like that. And 10 to the power of 80 is the number of atoms in the observable universe. So that's interesting.
Yeah, that's why I said that it's a large number. It's beyond what you can imagine, and you also mentioned that the number of possible positions in chess can be stored in memory. However, in Go, we definitely can't store it in memory. We can't even store it in the observable universe, let alone in memory. So and it is like a level up from Deep Blue, because Deep Blue just searched through all the possible combinations and brute forced as many as possible until time expired, until it found the best one. Whereas AlphaGo actually learned high-level, very high-level play of Go, and in fact, if you look up the videos and the commentators and the games between Lee Sedol and AlphaGo, they tell you these kinds of plays, you only understand them after 20 years of play. Because only then can you appreciate the complexity of how it played the long game. And also the very interesting part was AlphaGo was taught on Google Cloud, hundreds of GPUs on Google Cloud in 28 days. But not long after, they released AlphaGo Zero, which used a different method, which learned in 3 days it could surpass AlphaGo's abilities. So even there's not improvements only to be made on the theoretical side of AI of how we should learn, but also how we can make learning easier, but also on the hardware and how we teach it. So yeah, if you will, because I found this a bit difficult. I was like, what's the point of beating chess? What's the point of beating the best player of Go at Go? The hope of beating something like Go, and there's also a very big OpenAI have a big project about creating an AI which will defeat even professional players at Dota 2, is that the method needed to teach the AI to defeat the best players at these games, hopefully, and is resulting in a general way of even learning how to solve other problems, such as how to say diagnosing cancer way in advance when you can catch it at stage 1 rather than an advanced stage. The hope is that the same way you solve this problem, you can solve the other problem, because it might seem a bit like, what's the point of like beating a game? So when we beat each other in games, we usually either win a prize or win bragging rights. But the hope is that we also win a way of teaching AI to solve larger problems which we can actually apply in medicine, in transport, in economy, in the environment, and so on. So that's why AI excites me. But this talk was born of, there's a lot of hype, there's a lot of misinformation, so let's like set the record straight. Next. Any questions? Now's your chance.
Nice note to go off. I have a book question. When's the next one? You're doing the next talk about AI.
I could do one about strong and weak AI. The difference is, so there's this famous test called the Turing Test.
Yes.
The Turing Test it's usually, you read a lot of articles which are like, this bot from this university beat the Turing Test. Are we obsolete as humans? When in reality, the Turing Test is a test for whether your AI is weak. So is the AI capable of exhibiting intelligent behavior? It doesn't actually test for whether the AI is strong or not, which is whether it actually can consciously think, has thoughts, emotions, if you will, and so on, which is a much more philosophical concept. And there's a, what's the word? There's like a disagreement. There's a thought experiment called the Chinese room, which like it says, like we'll never have strong AI because of this thought experiment. Which I can do a talk about that next time.
The most human, because the human that can convince the most judges that he is a human. The Turing test is a human against a machine, confederates being asked questions. So the human that can convince most judges that he is human gets the most human prize as well.
And in fact, just to touch on this, the Turing test, and I'll actually leave something for the talk. For example, exhibiting intelligent behavior is knowing when to lie. I'm a fan of, like if you don't know something in an exam, it's better you just bullshit an answer and at least write something down, because for all you know, you might write something correct. And I'm like lying there, but I'm trying to lie about my intelligence. And in the Turing test, if the weak AI is intelligent enough, it might actually lie about how fast it can process. If I ask you what's 17 times 13, you'd be like, hold on, give me a piece of paper or I'll reach for a calculator. Whereas a computer can do it like this. But the computer will say, if I want to game the test, then I have to lie. I have to pretend that I am not capable of doing the calculation in an instant. So yeah, we'll talk about it next time. Any last call, questions?
Just on that point, that Google released.
AlphaGo, TensorFlow, which one?
The video they released where it makes a phone call and actually
Google Duplex.
So apart from line, even just that stammering or more
Yes, but that's also a part of, we don't really want a good AI sometimes. Sometimes we just want a convincing one. And that sometimes is enough. If anyone's not aware, Google released a demo of a project called Google Duplex, where the AI calls a hairdresser and books an appointment, and it sounds perfectly like human. So there's actually two AI at play. There's AI which is creating conversation, and then there's AI, I think it's called Songbird or something along those lines, which is creating the convincing voice. There's also a project called Lyrebird, where they teach the AI on, I think it's speeches of US presidents. Again, any good AI needs a lot of data, and usually you should look for open sources of data. And for example, I think US president speeches are all made available online in time-stamped, what's the word? They're time-stamped transcripts. So you have both the audio version and the text version. So you have your audio, which is your input, and your text, which is your label. So perfect. There you can train your AI. And they train it on these speeches, and then they release, whenever a president or an ex-president tweets, they use text-to-speech with this convincing voice to like create how it would have sounded, and they tweet it out at that president again. So yes, and it sounds mostly convincing. Like there's a phenomenon where Bigfoot sightings have stopped ever since smartphones have high resolution cameras, because now it's hard to fake. But if you have a mostly convincing AI and you layer on some noise, something like the connection is a bit bad, then you have basically you can step in for a human.
I can't remember his name. I looked it up because I had the book. The most human about passing the Turing Test. And this person is called Robert Eichstein. He's a psychologist and editor of the scientific volume Parsing the Turing Test. He was dating Ivana for 4 months online until he realized that she was a bot.
So yes, in fact, to touch on this,
and he was the editor of Parsing the Turing Test.
There was the case of that affairs website, what was it called? Ashley Madison, I think, where they got hacked and their database got dumped, and there was a lot of weird revelations came out of that database dump. But one of them was that I think 90% of the females on the site were actually just chatbots. So it was all a big con where they'd like try to get males, which is the target market for affairs, onto the website where they'd have these online affairs, but most of these were just chatbots.
One of the founders of the Leibniz Prize that succeeded the Turing Test. He's one of the founders.
And yet he got. Yeah. Next. Any more questions? My time is now up. Yeah. Perfect time. Last time I gave this talk, it took an hour. Anyway. Thank you for the opportunity. Nothing else to say, but thank you for listening. If you have any more questions, you can come find me now. Or send me an email, like if you got like send slides, or you want to like give the talk to your manager so he stops about badgering you about including AI in your product. You can like reach me afterwards. So yes, next time I'll give a talk about weak and strong AI. Okay? Sounds good? Thank you.